But tomorrow you guys have your quiz on this chapter. I gave you guys the review assignment already for this unit, chapters 1, 2, and 3. Handed that out yesterday. On Monday, we'll go through the last two quizzes that you guys wrote. Well, chapter 2 and then chapter 3. And then your unit 1 exam is Tuesday, June 6th. Your final exam is scheduled for Monday, June 19th, 8:30 in the morning, here in this room. And remember that June 9th, the week from tomorrow, is the last day to hand in any missed assignments. So we're going to continue working on right triangles. Remember, you can only use the trig ratios, sine, cosine, and tangent ratios if you have a right triangle, which is what we're always going to have. We'll introduce a couple new things, them being the angle of elevation and the angle of depression. The angle of elevation is measured upwards from the horizontal. So it's an angle that is at the bottom of the triangle. So in the example that's given there, the angle of elevation from the house to the top of the tower is this angle at the bottom. Essentially, if your eyes are looking straight horizontally and then they rotate up to the top of the tower, that angle is the angle of elevation. Elevate means going upwards, so you're looking up. The angle depression is measured downwards from the horizontal, so that would be from the top of the tower down to the house. But one important distinction here is that the angle of elevation is inside the right triangle, but the angle of depression is not. It's outside the triangle. You need an angle inside the triangle. Okay? But the angle of depression, the one outside the angle, will equal the angle of elevation inside the triangle. So just to show you that, let's say that the angle of depression there was 60 degrees. Based on that, we could find the measure of the angle at the top of the triangle, because the angle of depression and this angle at the top would go together to form this right angle. So they would add to get 90. If the angle depression is 60, then the angle inside the triangle would have to be 30 degrees, because the two angles add together to get 90. So now we have two angles in the triangle. We have the angle at the top to be 30. The angle at the bottom is the right angle, which is 90. We can find the angle at the bottom on the left side, the angle of elevation, because the three angles of every triangle always add up to 180 degrees. Haven't talked about that yet in this course. You would have seen it in previous math courses, but that is true. Every triangle, the sum of the three angles will be 180 degrees. So if we say that that angle there is theta, we can say that theta plus 30 degrees, the angle at the top, plus 90 degrees, the right angle, they must add together to get 180 degrees. 90 and 30 add together to get 120 degrees. And then we'll subtract 120 degrees from both sides. To get theta by itself, 180 minus 120 is 60 degrees. The angle of elevation equals the angle of depression. The difference is that the elevation angle is inside the triangle, whereas the depression angle is outside. In order to use your trig ratios, you need angles inside the triangle. So if you're given the angle of depression, that will always equal the angle of elevation. The angle of depression from the top of an object down to the ground will be the same as the angle of elevation from the ground up to the top of that object. That will always happen. Those two angles will be equal. Okay? So, on the next page, Sean wants to calculate the height of the First Nations native totem pole. He positions a transit, which is a tool used to measure angles, 19 meters to the side of the totem pole, and records an angle of elevation of 63 degrees to the top of the totem pole. The height of the transit is 1.7 meters, what is the height of the totem pole to the nearest tenth of a meter. So we've got the diagram there and it's labeled for us. Okay, so the totem pole goes all the way down to the bottom, to the ground. So the transit is 1.7 meters. So whatever we get for h, the height of the triangle, we're going to have to add the 1.7 meters onto it to get the entire height of the totem pole. But to find that, we'll do what we have been doing all along. We label the sides of the triangle. The side across from the right angle is the hypotenuse. You're going to use that 63-degree angle. The side across from that is the opposite. The third side is the adjacent. In this case, we're going to use which two sides, Keen? Which two sides are we going to use? If you were paying attention, you'd know. Pay attention. We're trying to find h, the height of the triangle, and we're given the adjacent side, how far the transit is away from the base of the totem pole. Those are the two sides we're going to use. Opposite and adjacent. Which uses which ratio, Sal? I don't know. I'm asking you. You can't answer a question with a question. Opposite and adjacent. Tangent. The tangent of the angle, which is 63 degrees, equals, and again, the order matters. You look on the formula sheet, it tells you it's opposite on top, adjacent on the bottom. So it'll be h over 19. We make the left side a fraction, so we can cross multiply. 1 times h will equal 19 times the tan of 63 degrees. And then we go to our calculator, make sure that you're in the correct mode. And I am. So now I can go 19 times the tan of 63. H, the height of the triangle, is 37.28. But to get the height of the pole, you need to add the 1.7. So the height of the pole, the totem pole, will be found by taking that number and adding the 1.7 meters. That is the height of the transit. To the nearest meter, 39 meters. That's the height of that totem pole. All right. On the next page, Natalie is rock climbing. Natalie is rock climbing, and Aaron is belaying. So the person that's belaying is the person that holds that rope. Okay, the climber has a rope attached to them, and it goes up to the top. Usually there's a pulley system up there that the rope goes through. And then there's a person standing down here that holds the other end of that rope, so that if the person slips, then they're not going to come crashing down to the ground. So when Aaron pulls the rope taut, which means takes all the slack out of it, so the rope is straight. When he pulls it taut to the ground, the angle of depression is 73 degrees. If Aaron is standing 8 meters from the wall, what length of rope is off the ground? So the triangle is labeled. The angle of depression is on the outside of the triangle. It's from the horizontal downwards. But remember, that equals the angle of elevation. The angle of depression from the top of the cliff down to where Aaron is will be the same as the angle of depression from where Aaron is up to the top of the cliff. Those two angles are always the same. So we want to find the length of the rope. They've used letter H there. And Aaron is 3 feet from the base of the rock. So Chloe, what's our first step? What have we been doing the last couple of days? Label the sides of the triangle. The side across from the right angle is the hypotenuse. We're going to use the angle inside the triangle, 73, the angle of elevation, the angle at the bottom. The side across from that is the opposite. Third side is the adjacent. Cheney, which two sides are we going to use? The H1 and the A1? Hypotenuse and adjacent, because we want to find the hypotenuse and we're given the adjacent. So that's right, we need to use those two sides. We're not given the opposite, not asked to find it. Jensen, what ratio uses adjacent and hypotenuse? Again, you're answering a question with a question. It is cosine. So our equation will be the cosine of the angle, which we know is 73 degrees, and again, the order matters. The formula tells us that it's adjacent on top, hypotenuse on the bottom. In this case, we make both sides a fraction, we cross multiply, and we don't have h by itself after cross multiplying. We have to do one extra step, which is divide both sides by cos of 73. Those will cancel on the left. You'll have h by itself. And we'll find out what it is by going 8 divided by cosine of 73. So 27.4 doesn't tell us what to round to, so I'm going to round to the nearest tenth. 27.4 feet. We're told that Aaron is 8 feet from the base of the cliff, so h will be in feet as well. So for those two, the triangles were given for us, but that's not always going to be the case. Sometimes you need to draw your triangle. The next question says a balloonist decides to use an empty football field for his landing area. When the balloon is directly over the goalpost, he measures the angle depression to the base of the other goalpost, and it's 53.8 degrees. Given that the distance between goalposts in a Canadian football field is 110 yards, determine the height of the balloon. So, if we draw kind of a diagram of what's happening here, you've got one goalpost, and then you've got your second goalpost. The hot air balloon is over top of one goalpost, and the angle of depression down to the other goalpost is 53.8 degrees. And remember, the angle of depression is measured downwards from the horizontal. That angle is outside the triangle, because the triangle that we need to work with is that one there. We are told that the distance between the goal posts is 110 yards. We want to find h, the height of the balloon. the height of this triangle. Now again, the angle of depression is outside the triangle. We need angles inside the triangle, but we've also learned that the angle of depression from the balloon down to the other goalpost will be the same as the angle of elevation from the other goalpost up to the balloon. And now we have an angle inside the triangle. But before we can find it, we need to label our sides. The side across from the right angle is the hypotenuse, which we're not going to use here. We don't care about that distance. The side across from the 53.8 degree angle that's inside the triangle is the opposite. We're going to use that. And we're told the distance between the goalposts is 110 yards. That's our adjacent side. We're going to use that as well. We're going to use opposite and adjacent, which is the tan ratio. The tan of the angle, which is 53.8 degrees, equals. And the definition of tangent is its opposite over adjacent. Make both sides a fraction, cross multiply. 1 times h will be 110 times the tan of 53.8 degrees, which we can do in our calculator. And the answer will be, if I round to the nearest tenth, 150.3 yards. That's how high the balloon is. All right. Now, when you're asked to solve a triangle, that means find all missing sides and all missing angles. That's what solving means. Question? Real quick. Find all missing sides and all missing angles. So let's start first by finding angle A. We've got 2 angles of a triangle. We can find the third. The 3 angles of the triangle always add up to 180 degrees. Or we can find angle A by going 180 minus the other 2 angles, minus 90, minus 42, which I think is 48 degrees. So there's the measure of that angle. So now we have to find the 2 missing sides of the right triangle. It doesn't matter which one we find first. I'm going to decide to find the side across from the 42 degree angle. When triangles are drawn like this, normally we use capital letters to represent the angles. The side across from each capital letter will be that lowercase letter. So the side across from angle B would be little b, the side across from angle A is little a, the side across from angle C is little c. This is normally done. And if you go into 20-1 next year, you're going to learn about working with triangles that are not right angles, using 2 laws known as the law of sines and the law of cosines. There is no law of tangents, but law of sines and law of cosines will use this, where angles that have capital letters and the sides across from each angle is the lowercase letter. So I'm going to find little b first. So if I label the triangle, you already know the hypotenuse. The side across from angle 42 will be the opposite. That's what we want to find. The third side is the adjacent. I'm going to find little b first. I'm going to find the opposite. So I will use the hypotenuse because we're given that. And I want to find little b, the opposite. So I'm going to use the sine ratio. The sine of angle B, which is 42 degrees, right? We use that angle to label our sides. The side across from that angle is my opposite. So that's the angle we're using. And the definition of sine is that it's opposite on top over hypotenuse on the bottom. Make both sides a fraction so we can cross multiply. 1 times b is 22 times the sine of 42 degrees. And little b is approximately 14.7. So it does say round to the nearest whole unit, so that would be approximately 15. And that will be in centimeters because the hypotenuse is in centimeters. So now all we have left to do is find little a. Remember, solving means finding all missing sides and all missing angles. And we can do that by using a trig ratio if we want, or we could also use Pythagorean theorem. If I use Pythagorean theorem, a squared plus b squared equals c squared. I want to find little a. Little b, we said, was 15 if we rounded it, but we need to keep the entire number in our calculator. So I will round it to write it down, but I'm going to keep the entire number in the calculator when I go to calculate. So a squared plus b squared equals c squared. So we could say that a squared is 22 squared minus 14.7 squared. So now we'll go to the calculator. 22 squared minus my previous answer, the entire decimal squared. A squared is 267.3. Again, that's an approximate because I rounded it. And now we'll take the square root of that to get a. So a would be approximately 16 centimeters. So that was done using Pythagorean theorem. We also could have done this using a trig ratio. If I use the 42 degrees and the hypotenuse, because we're given those, I would want to find little a, which is the adjacent. Cosine uses adjacent and hypotenuse. So if you use a trig ratio, we would say the cosine of 42 degrees equals adjacent over hypotenuse. Make both sides a fraction before we cross multiply. 1 times a equals 22 times the cosine of 42 degrees. And if you do that on your calculator, you get the same answer that we just got using Pythagorean theorem. Exactly the same answer. You would only get that if you do what we did with Pythagorean theorem, meaning keeping all those numbers in our calculator. But you get the same answer, exactly. Okay, so that's what solving a triangle means. I'm going to go on to the next page, and let's look at this question. So, from a height of 50 meters in his fire tower, a ranger observes a fire, or the beginnings of two fires. One fire is due west at an angle of depression at 9 degrees, so that means the angle of elevation is also 9 degrees. The other fire is due east at an angle of depression of 7, so that means the angle of elevation is 7. What is the distance between the two fires? So to do this, we have to use two triangles here. So let's label some points here on this in this diagram. So we'll say that's A, that's B, that's C, and up there is D. So what I need to do is I need to find the distance between A and B in the first triangle, and then I need to find the distance between B and C in the second triangle and add them together. We want to find the distance between the two fires. And we can only work with individual right triangles. So that's what we need to do. If I label the sides, the side across from the right angle of that first triangle is the hypotenuse. I'm going to use the 9-degree angle. The side across from that is the opposite. The third side is the adjacent. I need to find AB, which is the adjacent side. And so I'm going to use the opposite because I'm given that, and the adjacent. That's our tan ratio. We're not given the hypotenuse, not asked to find it, not using it. The tangent of the angle, which is 9 degrees, equals its opposite over adjacent, and our adjacent side is AB. If we make the left side a fraction and then cross multiply, we'll have AB times the tan of 9 equals 50. And so AB will equal 50 over tan of 9 degrees. And if you put that in your calculator, you will get 315.7 if we round it. And that'll be in meters, the same as the height of the tower is in meters. So now we'll do the same thing for the triangle on the right. Only now the angle of elevation is 7 degrees. The hypotenuse, we're not going to use. The opposite is still 50, and the adjacent side is what we're trying to find. That's the length of BC. Once again, we're going to use opposite and adjacent, which is our tan ratio. But again, in this case, now the angle is 7 degrees. And the definition of tangent is opposite over adjacent. And here the adjacent side is BC. Make both sides a fraction, cross multiply. And then we need to divide both sides by tan of 7 to get BC by itself. So 50 divided by tan of 7. Approximately 407.2 meters. And then the total distance will be found by adding those two together. And to be as accurate as possible, it does say to the nearest meter, but to be as accurate as possible, when I add the 315, I'm going to put in a few decimals here. I got 6, 8, 7, 5, 7, 5, 7. I'll put them all in. And so, to the nearest meter, it would be 723 meters. Almost 3/4 of a kilometer, which would be 750 meters. Okay, so there's that one. The next one, from his hotel room overlooking Saskatchewan Drive in Regina, Ken observes a bus moving away from the hotel. The angle of depression of the bus changes from 46 degrees to 22 degrees. We want to find the distance that the bus traveled if his window is 100 meters above the street. And we want to express that to the nearest meter. So where the last question was two different right triangles, this one here is going to be one right triangle embedded in another. This diagram would look something like this. So the height of this triangle is how high the window is above the street. That's 100 meters. The first angle of depression is 46 degrees. So that will be when the bus is closer to the hotel. And remember, the angle of elevation from the bus up to the window at that point will be the same, which again, we need angles inside the triangle. The second angle of depression, as the bus has moved further away from the hotel, is 22 degrees. And that will equal the angle of elevation from the bus at that point up to Ken's window. We want to find the distance the bus traveled, which is the way I've labeled my triangle here. We need to find the distance from B to C. And B to C is not part of a right triangle, that side. It's part of a triangle that's not right angled. So we cannot find it directly. What we have to do is we have to find AC, which is the base of the large triangle, and subtract AB, which is the base of the smaller right triangle. That's what we need to do here to get what we're looking for. So there's our right angle. Let's find AC first using the large triangle. The side across from the right angle is the hypotenuse. We're going to use the 22-degree angle. The side across from that is the opposite, which we're given. And AC is the adjacent side, which is what we're trying to find. We're not given the hypotenuse, not asked to find it, not going to use it. We're going to use the opposite and the adjacent. To find the length of the adjacent, which in this case will be side AC. Opposite and adjacent, again, is our tan ratio. The tan of the angle, which is 22 degrees, equals the opposite, which is 100, over the adjacent, which again will be AB. Excuse me, AC. I'm using the 22-degree angle, so it has to be AC. Make the left side a fraction, cross multiply. And then we have to divide both sides by tan of 22 to get AC by itself. So 100 divided by the tan of 22. AC is 247.5. And that'll be in meters because that's what the height is. And I'm going to store that number into my memory because I'm going to need it. So now we need to find AB. And the triangle will be labeled the same. We're just going to use a different angle. But 100 is still the opposite. The adjacent side is AB, which is what we're looking for. So we will use the tangent again, only now the angle is 46 degrees. And it equals opposite, which is 100, divided by adjacent, which is AB. Cross multiply. And then divide. Divide both sides by tan of 46. So 100 divided by the tan of 46 is 96.6 approximately. Meters. And as we've said, to find the length of BC, we need to subtract those two sides. So our distance will be found by subtracting those two sides. So memory slot A minus the previous answer, 150.9 or approximately 151 meters. It says to the nearest meter, so there it is. Okay? So, on page 21 and 22, there's an assignment for you to work on. I will post this solution to Google Classroom so you can check your answers, but I would encourage you to do it and check your answers. So remember, tomorrow you have your quiz on Chapter 3. We'll be going through the Chapter 2 and Chapter 3 quizzes on Monday. You'll also have time tomorrow and Monday to work on your review assignment to help get you ready for your test on Tuesday. After that, we will review for your final exam, which is Monday, June 19th. So we're going to have 2 days next week because Friday's a PD day, and then I think there's be 4 days the next week to review as well before the last day of classes. Yes? Yeah. Also remember, next Friday, last day to hand in any missed assignments. No excuses, no extensions.